A sanctuary born, the world's first national park, Yellowstone. The name itself conjures images of raw, untamed wilderness. It stands as a testament to a grand idea, an idea born in the American West. This was to be a place set aside not for development but for the benefit and enjoyment of all people. On March 1, 1872, this vision became reality. President Ulysses S. Grant signed the Act of Dedication. Yellowstone National Park was thus established. It was a revolutionary concept for its time. The world had never seen anything quite like it before. This act marked a profound shift in how humanity viewed its relationship with nature. For centuries, wild lands were seen primarily as resources to be conquered, tamed, or consumed. Yellowstone represented a different path. It was a recognition of intrinsic value, the value of geysers erupting with primal force, the value of vast forests teeming with wildlife, the value of landscapes sculpted by ancient geological dramas. This park was to be a public park or pleasuring ground, a sanctuary preserved for future generations to witness and to cherish. The establishment of Yellowstone was not without its challenges. Early expeditions brought back tales of its wonders, stories of boiling mud, petrified trees, and steaming rivers. Some accounts were met with disbelief. They sounded too fantastical to be true. Beneath the stunning landscapes of Yellowstone lies a secret of immense power, a geological feature of terrifying potential. The park sits atop one of the largest active volcanic systems in the world. This is not just any volcano. It is a supervolcano. The term itself hints at something beyond ordinary experience. A supervolcano is defined by its ability to produce eruptions of extraordinary magnitude, eruptions that can eject more than 1,000 cubic kilometers of material. This is enough to bury entire states under layers of ash. The Yellowstone caldera, as it is known, is a vast depression in the earth. It measures roughly 45 by 30 miles. This caldera was formed by colossal eruptions in the distant past. It is, in essence, the collapsed mouth of this giant. Deep beneath the surface, a massive plume of molten rock or magma rises from the Earth's mantle. This magma chamber is the engine driving all of Yellowstone's famous geothermal features. The geysers, the hot springs, the fumaroles, all are surface manifestations of this immense heat source below. It is a constant reminder of the fiery heart beating just beneath the park's serene facade. Understanding the scale of this subterranean giant is difficult. The Yellowstone supervolcano has not always been a quiet giant. Its history is punctuated by eruptions of unimaginable violence. The most recent of these cataclysmic events occurred approximately 640,000 years ago. This eruption, known as the Lava Creek eruption, was one of the largest volcanic events known to science. It was this event that formed the current Yellowstone caldera. The scale of this ancient explosion dwarfs any volcanic eruption in recorded human history. It reshaped the landscape for thousands of square miles around it. The Lava Creek eruption ejected an estimated 240 cubic miles, or 1,000 cubic kilometers, of rock and ash. This material spread far and wide across what is now the United States. Ash layers from this eruption can be found as far away as Iowa, Louisiana, and even California. The immediate vicinity would have been utterly devastated. Pyroclastic flows, superheated avalanches of gas, ash, and rock, would have surged across the land. They would have incinerated everything in their path. The sky would have darkened for months, perhaps years, as fine ash particles circled the globe. While the supervolcano slumbers, its influence is vividly expressed on the surface. Yellowstone National Park is a geothermal wonderland. It boasts the world's largest concentration of geysers. There are also thousands of hot springs, mud pots, and fumaroles. These features are direct conduits to the heat emanating from the magma chamber far below. They create a landscape that seems almost otherworldly, a place where the earth visibly breathes, steams, and boils. This constant activity is a major draw for millions of visitors each year. Old Faithful is perhaps the most famous geyser on the planet. Its predictable eruptions have captivated audiences for generations. But it is just one of many. Steamboat Geyser, the world's tallest active geyser, can hurl water over 300 feet into the air. Grand Prismatic Spring, with its vibrant bands of color, is a stunning example of thermophilic bacteria thriving in extreme conditions. These colors are created by different species of microbes. Each species is adapted to a specific temperature range within the spring's outflow channels. The doomsday scenario, imagining the unimaginable. The thought of another super eruption at Yellowstone is, frankly, terrifying. While scientists stress the low probability of such an event in any given year, its potential consequences are so vast that they demand consideration. A full-scale eruption of the Yellowstone supervolcano would be a catastrophe of global proportions. It would dwarf any historical volcanic event witnessed by human civilization. The immediate effects in the vicinity of the park would be apocalyptic. Nothing would survive within a radius of many tens, perhaps hundreds, of miles. The eruption column would soar high into the stratosphere. It would carry billions of tons of ash, rock, and volcanic gases. Pyroclastic flows, those incandescent clouds of death, would surge across the landscape at incredible speeds. They would bury everything under hundreds of feet of superheated debris. The states of Wyoming, Montana, and Idaho would bear the brunt of this initial devastation. Cities and towns would be obliterated. The landscape would be transformed into a sterile gray wasteland. It is a scenario straight from a disaster film. Yet it is a genuine geological possibility. A blanket of ash, the far-reaching consequences. The most widespread and disruptive consequence of a Yellowstone supereruption would be volcanic ash, vast quantities of it. This fine, abrasive material would be carried by prevailing winds across North America. Within days, much of the United States could be covered. The thickness would vary. Areas closest to the eruption might see several feet of ash. Even cities thousands of miles away could receive inches. This blanket of ash would bring modern society to a grinding halt. It would be a silent, suffocating menace. Infrastructure would collapse under the weight of the ash. Buildings would buckle. Roofs would cave in. Power lines would snap. Water supplies would become contaminated. The ash, when wet, forms a heavy, cement-like sludge. This would clog drainage systems, leading to widespread flooding. Transportation would become impossible. Roads would be buried. Railway lines would be unusable. Air travel would be grounded globally. Volcanic ash is incredibly hazardous to jet engines. Even a small amount can cause them to fail. The economic disruption would be unprecedented. Agriculture would be devastated. The Earth's subtle shifts, tremors and ground movements. Yellowstone is a geologically dynamic place. Even in its current state of repose, the supervolcano makes its presence known. The ground beneath the park is constantly, subtly on the move. Scientists monitor these movements with incredible precision. They use GPS stations, satellite radar, and tilt meters. These instruments reveal a pattern of uplift and subsidence. The entire caldera floor can rise or fall by several inches, or even feet, over decades. These movements are believed to be caused by changes in the volume of magma or hydrothermal fluids within the underlying reservoir. For instance, from 2004 to 2010, parts of the caldera floor rose at an unusually rapid rate. Some areas uplifted by as much as 10 inches. This caused some concern and media attention. However, since then the rate of uplift has slowed, and in some areas subsidence has occurred. Such cycles of uplift and subsidence are considered normal for large caldera systems like Yellowstone. They do not necessarily indicate that an eruption is imminent. They are rather signs that the volcanic system is active and breathing. The magma chamber is not static. It is a living, changing entity. Science and speculation. Understanding the giant slumber. Geologists and volcanologists who study Yellowstone offer a message of cautious reassurance. The United States Geological Survey (USGS) is at the forefront of this research. They state that the probability of a catastrophic supereruption in any given year is exceedingly low. The current estimate is about 1 in 730,000 or 0.0014%. This means that statistically, such an event is far less likely than many other natural disasters. Scientists emphasize that there are currently no signs of an impending eruption. The system is being monitored intensely, and any significant changes would likely be detected well in advance. However, the sheer scale of potential devastation keeps speculation alive. The historical pattern of major eruptions, roughly every 600,000 to 800,000 years, is often cited. Given that the last supereruption was about 640,000 years ago, some wonder if we are due for another. Scientists caution against this simplistic interpretation. Volcanic systems do not operate on precise timetables. The intervals between past eruptions are averages, not strict schedules. Furthermore, recent research into magma movements beneath Yellowstone provides a more nuanced picture. It shows the system is active but not necessarily building toward an immediate cataclysm. The enduring watch, Yellowstone's volcanic future. The volcanic hotspot that fuels Yellowstone is not a permanent fixture. The North American plate drifts southwest over a stationary plume of hot mantle material. This movement creates a trail of ancient calderas across southern Idaho. Each caldera marks past volcanic activity similar to Yellowstone today. Eventually, the hotspot's focus will move away from Yellowstone. In the distant future, volcanic activity might shift northeastward. Yellowstone could cool down and its geysers might fade. Seismic activity might lessen, and the supervolcano would migrate with the hotspot. For now, Yellowstone remains an active volcanic center.